Okay, in this video I'm going to be talking about the graphs of trig functions and why we must restrict their domain when we want to find the inverse of a given trig function. Okay, so suppose this is our given sine function. This is just going to be y, let me use blue, this is y equals sine of x. Now, for this function, this should not go above positive 1 here. Let me just clean that up a little. So, for this function to have an inverse, the function must be 1 to 1. Now, this function is not 1 to 1. A quick way to see this is because this does not pass the horizontal line test. I can draw a horizontal line through this graph and it will hit at actually an infinite number of places. So what we need to do is we're going to limit the domain of this function so that it does become 1 to 1. In other words, we want it to only hit the graph in a single spot. A horizontal line hit the graph in a single spot, no matter where we draw that horizontal line. So for the sine graph, what we do is we restrict the function, the domain of this function, to be between these two values. So that's negative pi over 2 and pi over 2. Now, the reason we do this is so this part of the graph now, let's see if I can draw over this. So this part of the graph now will pass the horizontal line test. In other words, this section of the graph is 1 to 1. So now, because this section of the graph is 1 to 1, we can find the inverse of just this section. Now, you may be asking yourself, well, why do we pick this section? And it's true, we could pick this section of the graph right here. That would be between 3 pi over 2 and 5 pi over 2. That section would also be 1 to 1. There are an infinite number of sections or snapshots of the sine graph that we could look at that will allow the function to be 1 to 1. So we pick this section that is near the origin because these values are very familiar to us. These values between negative pi over 2 and pi over 2, those are on the unit circle if we're looking at the first rotation around the unit circle. This is looking at the fourth quadrant and the first quadrant. So that's one reason we would restrict from negative pi over 2 to pi over 2. You know, we don't want to look at 13 pi over 2 to, I don't know, 17 pi over 2 or 13 pi over 2 to 15 pi over 2 because those values aren't familiar to us. We don't readily know what the value of sine at 15 pi over 2 is. However, we are familiar with the values that are in this given range. Secondly, we select negative pi over 2 to pi over 2 because if we were to start here at 0 and go to pi, which would be right here, that is not going to pass the horizontal line test. If we start at 0 and end at pi, that does not pass the horizontal line test. So by, again, selecting negative pi over 2 to pi over 2, we have a section of the graph, and it's the biggest possible section that we could look at that passes the horizontal line test. So the reasons that we restrict the domain to negative pi over 2 to pi over 2, because this allows for the function to be 1 to 1, and only functions that are 1 to 1 have inverses. Secondly, by restricting from negative pi over 2 to pi over 2, we get all the y values. Every single y value from negative 1 to positive 1 is included. So by restricting the domain, this allows us to find all values of the function. Again, if we look from 0 to pi here, 1, first of all, this is not going to be 1 to 1. Second of all, we're only getting positive values of the function. We're not getting any negative, we're not getting any values down here. So we want to, by restricting the domain, we want to make sure that the function is 1 to 1. We want to make sure that we get all the values of the function. All right, let's take a look at the cosine function. Now, for cosine, again, we want to follow the exact same procedure as what we did with sine. We want to restrict the domain of this function so that we have a section of the graph that is 1 to 1 that also allows us to get all of the y values, or all of the values of the function. Okay, so we want to achieve these same goals. All right, now our initial idea may be, well, let's look at the same domain as we had for the sine function. That was negative pi over 2 to pi over 2. If we do that, we're only going to get positive values of the function, and also this is definitely not 1 to 1. So we don't want to restrict between negative pi over 2 to pi over 2. So what we do with the cosine function is we start at 0, we go down to this position, and that is at pi. So between 0 and pi is how we want to restrict this domain. Now again, we could have looked at negative pi here to 0. That would have achieved the exact same goal. It would have been 1 to 1, and we would have gotten all the possible y values from negative 1 to 1. However, again, just for familiarity's sake, and for evaluating the function at these different x values, it's going to make things easiest if we go from 0 to pi, where we only have positive angles that we are inputting into the function. All right, so looking at the tangent graph, what we do is we restrict between negative pi over 2 and pi over 2. Now, the reason that, it may seem like, oh, why don't we restrict between 0 and pi? That looks like we would pass the horizontal line test. And now that would be true if we don't include 0 and pi as our end values. So if we did 0 to pi, that looks like that would pass the horizontal, or that looks like that would pass the horizontal line test, and therefore trait 1 would be satisfied. However, the problem is this asymptote that's going down, this vertical asymptote at pi over 2. Now, this asymptote is saying we will never get a y value that is equal to 0. We never are going to get y equal to 0 here. So while the first property is satisfied, this second property is not satisfied because we do not get all the values between 1 and negative 1. So what we need to do is we restrict from negative pi over 2 to pi over 2 for a tangent graph. So this is y equals tangent of x. All right, so let's go back to the sine graph and let's look at the reciprocal of sine, which is y equals cosecant. Let's look at what that graph looks like. Now, remember, the cosecant graph, let's see, I wanted to redraw this sine graph with our restricted area from negative pi over 2 to pi over 2. Again, this allows for the function sine of x to be 1 to 1 and to give us all the values of the function from negative 1 to positive 1. Now, how the cosecant graph works is, well, we have asymptotes wherever the function crosses 0. So, this cosecant graph is going to, we have one more asymptote right down the middle. So this cosecant graph is going to look like this, it's going to look like this, and so on. So it's the same idea. We want to restrict this so that we have a function that is 1 to 1 and that we get all values of the function, the cosecant function. Now, if we restrict this from negative pi over 2 to pi over 2, we're going to get all possible values for the cosecant function. we're going to get from 1 to infinity and from negative infinity to negative 1. And then also, this is going to be 1 to 1. So this part of the graph right here, and this part of the graph is 1 to 1. So if we just take kind of cutting those parts of this cosecant graph in half, and just looking at this one down here and this up here, we have a domain from negative pi over 2 to pi over 2 that allows for the function to be 1 to 1, and also gives us all values, all possible values that would appear for the cosecant function. I'm not going to go through the secant graph. It follows the exact same idea as the way the sine graph and the cosine graph, or sorry, the way the sine graph and the cosecant graph relate to each other is similar as the way that cosine and secant relate to one another. However, tangent and cotangent are slightly different, so let's investigate that. Alright, so let's look at a cotangent graph. Now, the tangent graph we restricted between negative pi over 2 and pi over 2. If we were going to do that for the cotangent graph, that would be a problem because we're never going to get a value that is y equal to 0 because we have an asymptote at that value. We're never going to get this value on the y-axis. So what we need to do is we actually restrict the domain for cotangent between 0 and pi. And we don't include those endpoints because those are asymptotes. The function is undefined at those values. So we restrict the domain from 0 to pi, and this is this relationship between tangent and cotangent is different than the other reciprocal functions and how they relate to each other. In sine and cosecant, as well as secant and cosine, we restrict the domain in the exact same position. For tangent and cotangent, though, we restrict the domain differently. So looking back, for tangent, we said from negative pi over 2 to pi over 2. For cotangent, it's 0 to pi. Okay, now we know a little bit about how we restrict the domain for all the trig functions. Now I think you'll be able to hopefully understand how the inverses, we can get the inverses from these restricted trig functions.